Guys, welcome back. Today we're looking at lesson 13.1, linear proportional relationships. The learning target of this lesson today is we're going to be able to distinguish between proportional and non-proportional situations using tables, graphs, and equations. Thank you for marking up everything that I'm putting on my notes. Thank you for writing them on your notes so you can help learn this lesson. Number 1 says create a table of values for the 3 equations below. Once we create the table of values, we're going to graph the equation, and then we're going to look at any similarities and differences that we see. So the first challenge in this is picking some x coordinates. Since it's all blank, we need to choose the x coordinates. And what you'll notice is our x-axis goes from -10 to +10. So we can really pick any number between -10 and +10. However, we want to try to keep it on this graph, on this coordinate grid, so we can see what the function looks like and be able to display the graph of this equation, y is equal to 2x. So what I'll do is I'll just pick some. You can pick any numbers that you want, but I'm going to go ahead and pick -4, -2, 0, 2, and 4. And so if we plug these numbers in for x, so if I plug in -4 right in here, into x, it becomes 2 times -4. 2 times -4, our y would be equal to -8. So that point, -4, -8, would be right here. I'm going to put a point there. Now I plug in -2 in for x. -2 times 2 would be -4. So that point, -2, -4 would be here. If I plug in 0, well, 2 times 0 is just 0. So that point goes right through there. 2 times 2, that's 4. This point, 2, 4 would be here. And 4 times 2, once I plug in that, would be 8. So that coordinate point would be where x is 4 and where y is 8, which would be here. What you'll notice is this forms a straight line. This actually forms what's called a directly proportional relationship because it has two things. And I'm going to make this blue here. It has two things. Maybe I'm not, hold on. Here we go. So let me draw this line. Okay, so this is directly proportional because of two things. It goes through the origin. Number 1, it must go through the origin. I'll just write a number 1 over here and I'll write origin. You can write that in your notes for you to remember. O-R-I-G-I-N, origin. And then number 2, it has to be linear, meaning it's a straight line, has a constant rate of change. If for these two reasons, if it goes through the origin and it is a linear function, then yes, it is a proportional relationship. Okay, let's try the second one, B. Y is equal to x squared. So here again, you can pick any numbers that you want. Let's make sure that it stays on the graph though. So I'll do -3. Actually, you know what? Why don't I go ahead and do -2, -1, 0, 1, and 2. So when I plug in for x, I'll plug in these values into here. -2 squared, or -2 times -2, would give you a +4, because a negative times a negative is a positive. So that point, -2, -4 would also be right there. Now we have when x is -1, so -1 times -1 gives you 1. -1 times -1 gives you 1. And then 0 would be 0. 0. 1 times 1 is 1. And then 2 times 2 would be 4 again. So 2, 4, that point would be here. Notice how this line is actually not a straight line. If we kept going, like let's say I had 3 here, 3 times 3 would be 9. So that point would be right there. Sometimes it's helpful to do even more than what's given. And if I do -3, it would be -3, -9, which would be here. So what you'll notice about this is that this line looks a little different from what we're used to seeing. It does go through the origin, it does go through the point 0, 0, but it is not linear. So it is not a linear function. It is not directly proportional. I want you guys to try letter C on your own. Press pause and come up with some values of x and solve for y. Good. Hopefully you press pause and you did this one now. You could have chose any values that you wanted. Notice that we have our y-intercept of -1, and we also have a slope of -2, so that could be a helpful hint there. Now, what you should see is that this is going to form three different types of equations. Matter of fact, I'm going to go ahead and plot what this orange one would look like. I'm not going to fill in the table. You're going to do that. But your table, or your graph, excuse me, would have looked something like this. This is what your graph should have looked like. It has a slope of -2, and it goes through the y-intercept, which is right here, where x is equal to, or where y is equal to 1. So your line would look like this. Now notice how these are three different kinds of lines. They are all different, but what I want you to do is press pause and explain what the similarities and differences are between these graphs. Do that now. Press pause. Okay, on the back side, I'll go ahead and I'm going to do B for you guys this time. I'm going to go ahead and do, actually, I'll do the hardest one. I'll do C. So I'm going to plug in some numbers here. So let's see, I'm going to do -2, -1, 0, 1, and 2 again. So when I plug in these values of x into this equation here, let's see what we get. So if x is -2, -4 times -2, that gives us -4 times +8. 8 plus 8 would be 16. Notice how that one actually goes off the graph. Our graph only goes up to 10. So that's not a good value to pick. Maybe I should choose some different values here. And let's see, I'm going to change this to, let's see, we already have 0, 1, 2. I'll go ahead and make this like 4. Let's see what we get when we plug in 4. So -4 times 4 is -16. -16 plus 8 gives you -8. So the first point we can have is where x is 4 and y is -8, which is right there. That's a pretty good point. So now I'll go ahead and do 2. Oh, no, I already have 2. Why don't we do something like 6? -4 times 6 is -24. -24 plus 8 is going to be -16, which will also be off the graph, so we won't worry about that one. But if I plug in 0 into here, then my point would be right there. If I plug in 1, -4, whoops, I need to put this down. -4 times 1 would be -4 plus 8. -4 plus 8 would be 4. So another point, another coordinate would be there. And then we have 2. So -8 times 2 is -8, and plus 8 would give you 0. So that point would be right there. Notice how I didn't have I picked random x values here, but it should still form a straight line because this is going to be a linear function. Let me move this over a little bit because I could tell it was a little bit off. So that's how I know. And notice how it goes through all 4 of my points. What I want you to do now is I want you to press pause, and I want you to do letters A and B. I'll go ahead and give you some values that I want you to plug in here for this. So for the first one, I want you to do -8. So I just picked different numbers for this one. What I want you to do is I want you to do those values. Press pause and do that now. Number 7, you'll see you have 1, 2, 3, 4, 5 different graphs. The question is tell whether, so explain whether the relationship is directly proportional or non-proportional, and then we have to explain the reasoning. So number 1, yes, it goes through, yes, I'll put yes, and it's yes because of 2 reasons. Number 1, it goes through the origin, as we talked about earlier, and number 2, it is also linear. Linear is L-I-N-E-A-R. For the second one, this one is actually no. No, it is not. It is linear, but it does not go through the origin, so therefore it is no. Please press pause and do the last 3 on your own.